Awesome.
We need to talk about NLP and we need to talk about data, guys. And time flies. So at least those two. We promised that as key themes.
Let's move into NLP then. And perhaps we should move into the SweBert project. And that's an interesting one. And SweBert formally is the Swedish language model for Swedish authorities project. It's a big one where RISE is involved and Peltarion and a number of Swedish authorities. Like the tax authority and the employment agency. And
so I asked a stupid question. What is SweBert?
Yeah, perhaps you like to give your description.
Okay. So there is this neural architecture, a model for learning things called a transformer. That sort of morphed into something a bit different called BERT, which I think the name BERT is from Sesame Street, and it was because the best model before that was Elmo. So now they call it Muppetware. Anyway, so
I've heard that actually.
That's so good.
That's really funny.
So and
who Google, right?
Yeah, Google did this. And
too much fun at work.
That's where I have
exactly.
To
and they, from what I heard, this is actually more of an engineering effort than a science effort. That's the rumor about BERT. Anyways, it's for English originally, but we perhaps need to do this in Swedish for Swedish for the Swedish society, and it requires some power in terms of computation and in terms of data and such. So perhaps I think the idea was that maybe no one singular commercial entity should do this, but maybe like the state should sponsor this, and we had a consortium with RISE and Peltarion and others to actually build models like this, and then a key player in this is Kungliga Biblioteket, Swedish National Library, because they have all the data.
A lot of data. Not all the data, but a lot of data.
But so there's
the most Swedish data, I think.
Yes. But there's for the uninitiated, there is a lot of unpacking here. We're talking about transformers. We're talking about language models. We're talking about using transformers to create BERT, which is a language model. And now ultimately the context is, can we use this technology and these open source frameworks and make a Swedish language model for general purpose?
Yes.
I would rephrase it as, can we make this language model work for Swedish as good as possible?
Yes.
Okay.
Yes, I know where you're going with this.
I don't. Now this was good because I don't understand the difference what you said to what I said, but there is a distinction.
I think we can move into this topic. So the topic then would be monolingual versus multilingual models.
Nice.
That's a nice segue. Yeah.
Cool.
But before we go there,
this is all NLP, but different facets. I love it.
Yeah.
Okay. No, but I think I really like this project in general. It's a 3-year project. It's financed by Vinnova and then in kind from the companies and partners that are part of it. And I also like actually that the public sector is so heavily involved. And I also must give some praise to the agencies that we do have in Sweden that are surprisingly innovative, I must say, and are able to work with the latest type of AI in ways that is a bit surprising to me, actually, and it's really in a positive way. So I'm really happy for that. But then still, of course, we want to make sure that the Swedish industry in general is able to use AI for Swedish text. I mean, that's a general goal, right? And then we have a number of, should we move into the contrastive tension as an example, perhaps? Or do you think that's a good topic? So we have a number of results already from this project. We're, I guess, 1.5 years into the project or something, less than halfway, but we already have some really cool results. If you were to speak about the contrastive tension, how would you describe that work?
Awesome. No,
that's a good way.
It's my colleagues. I wasn't really involved in it, other than talking and reading drafts of the paper. It's basically an idea by which you could train a language model to represent text in a way that you could measure for quantify the semantic similarity. That is the content of the text, the meaning of the text in a sense. So you can have two meanings that are phrased differently. That has different words in different order, but they mean essentially the same, and you can compare them by using this model. There are many different models by which you can do this, but this in particular is trained in something called an unsupervised way. So it means that you don't have to have like an answer key or annotations to do this.
From hell. Yeah.
No, exactly. So this is something that Fredrik Olsson at RISE came up with past summer, and together the team. And this is why I love to work at RISE so much, because the team that I'm working with is really good at picking up these things. Someone has an idea and they started bounce it off the walls, and then they come, do something with it. And one natural outlet for this particular idea was to write a paper, a scientific paper. And I saw in Slack today that they were actually working on the formatting of the camera-ready copy for the conference.
So it was accepted for one of the biggest AI conferences, iClear, right?
Yes,
And that's a really big thing.
Yeah.
So
this is huge, right?
Yeah, it's huge. I played around with it. I mean, that's also one thing that's really cool now. It's the path from research to actually using the research has never been shorter. So Fredrik did this, trained some models, uploaded them to GitHub with the example code, and you can download them from Hugging Face, which is one of the frameworks that you can use, and then I could play around with it at home. So it's really cool that way. But yeah.
But could we decompose a little bit like this? Because I sense or understand that transformers has really revolutionized machine learning space, and 80-90% of who is doing advanced analytics is not on the train in Sweden.
Say advanced analytics.
No, I mean, like we do AI, so you do machine learning, yes. And what do you do in machine learning? Well, not transformers, not even, maybe, not hardly even. So Luca would say traditional AI or advanced,
Analytics is different from AI, I would say.
Yeah, but okay. Let's simply be in the machine learning space, and then what is now the difference with transformers, and how does this relate into BERT? And then I think you could start unpacking it deeper and deeper and deeper and deeper. But you're starting so far ahead, where 90% don't even understand transformers.
So we could start by looking at the data and say that when you represent the data in the good old days, scikit-learn way, you did it by, and this is text and it's representation learning. You did it by counting words. And there's a scheme for weighting terms called TF-IDF. So term frequency, inverse document frequency. That's one way of doing it. It's very simple. It's still very competitive in certain tasks, which is worrisome because we want to do the cool stuff, right?
It is annoying.
Yeah, it's annoying when the old model is outperforming the cool stuff.
Really, diminishing returns some way to use different things. But what it ends up with, it you have like if you have a text encoded using bag of words, which is called, you have a set of words and you have the weights on it, you get a long vector for that text. This can do a lot of things, but it can't do things like synonymity and antonymity and semantic relations on the word level. So, and this is the next step was the word-to-vec things. Was it 2014 or what?
13, I think.
13, yeah. In that way, you could compute based on the context of the word. That is how the word is actually used in text. You could say something about its meaning, and I think the main idea is that if two words are used in a similar context, in similar sense, they mean pretty much the same thing or similar things.
Yeah. So instead of having a statistical kind of approach of counting term frequencies, you had a small neural network with a single hidden layer.
Yes.
Try to use the
So now we're going into neural networks at least.
Yes.
This is the first breakthrough with neural networks in this space.
So
first, but it's one of the big ones.
The big ones.
Okay. One of them. It's quite cheap to use, and there are variants of this, GLOV and fast text and word-to-vec.
And are they still useful in some cases?
Yes, in some cases I would argue they are, because what they can do is actually see things in context. In one way, you can have, if you have one type or one token, that is one expression on the surface text, like can't come up with an example, bank.
Paris Hilton, Paris the city.
Yeah, Paris Hilton. Yeah,
Paris
and she was conceived there, right? No, Paris Hilton.
Yeah. So, can you distinguish between a person and a city?
Oh no, you can't. You can't really do it. If you have like orange and orange, you have the fruit and the telecom company. What is it with telecom companies and bad naming? By the way,
Apple.
But Apple. If you talk about Apple on the interwebs, it's usually in plural. You have to say apples. So that's not too big a problem. That's something I learned at Gavagai.
Anyways,
so you have the word thing. You can actually say something about the words in the sense that if you have a representation of a text based on Word2Vec, you could say that two texts, one having Paris Hilton and one saying something about Continental.
City of Paris.
So City of Paris or Paris Hilton and Continental something. You could say that Paris Hilton is one hotel and the other Continental is one hotel. So they're quite similar, despite not sharing any lexical features. So that's one thing. But then came Transformer and BERT. And Transformer is like we had this sequential networks before, but this is one way of encoding data in a way that you can actually have long-term dependencies. So if you have Paris Hilton, the name of a person, and Paris Hilton, the name of a hotel, you would have different representations for those particular things. And this is what these contextualized language models are actually doing.
And here I learned now we talk about attention is all you need.
Yes, exactly.
So explain attention in this context.
And attention in this context is a way of, to explain attention, I would say that you have to go back to look at how you did it with recurrent neural networks before. So you had the recurrence, that is, you have like a sequence of things, and then you could remember from previous sequences or previous states in the sequence something. But one of the problems there is that this memory sort of diminishes as you go along. So with the attention, you didn't encode it as a sequence. You instead encoded things, put it bluntly, as if I'm a word in a sentence, I have attention on certain other positions, because this is what means something to me. And these attention masks are also learned from the data. Perhaps
so it's something about the words in a context and the attention of what has been in the sentence before. It means that the logic should be around this.
Yes,
something like that.
So and these are, if you think of it in ways that you can actually imagine, these are too small. I mean, these are so big, the networks, and there are so many parameters. It's like functions that have billions of parameters that you could tweak.
Yeah, so MT5 is the new one.
Yes.
Yeah, I mean, in short, it's a big revolution.
And now go nerdy. Now we have introduced the topic to go. Now I want to go to the next.
Now
go.
Yes. And
now we go to
Transformers is not only single language; it's multilingual also, and it's also multimodal. That is, you're not only able to crack the language code, but also images.
Yeah. So what's the cool thing with MT5 to what it was done before? What is MT5?
So
sorry, I'm stealing it. You go now. Sorry, I don't know shit.
Blame yourself. I'm going to speak far too much about this now, but
please.
But Transformers, of course, from 2017 started as a translation model, and then BERT came and a general classification and regression type of network that was really revolutionized in so many ways, and being able to use in pre-training, which was a big thing with BERT. And that has really also changed, that you don't need as much annotated data, which this contrastive tension paper is also really much about. And I think, the normal kind of the thing that we spoke about before, which is what is really the biggest use for AI in industry, or for when you really use it in practice, is that, annotating data is really hard. It's easy in academia because you just use academic data sets, but in reality, you don't have that. You don't have annotations, but you have data in some way. Even PDFs, even though it's hard.
PDFs. Dirty text.
Dirty data. So the question is then really, how can you minimize the amount of annotated data? And I think BERT made a big revolution when it comes to that.
Because you have practicality now. It's not just a room text set, but it's actually real dirty data, and it can sort of sort it out.
And then the T5 paper came out like a year ago, and it actually went back from BERT to the original transformer and generates text. And it seems to actually be a way to just improve performance even more, which is kind of surprising. And then this multilingual approach came a couple of months ago.
Emmet is multilingual T5.
So training on 100 languages at once in a single model, moving it to a more generic model, seems to work surprisingly well. So you can even use something that's trained to do some task like sentiment analysis or question answering or some kind of text classification in English, and then directly apply it to Swedish without training for any Swedish annotated data at all.
And how does that concretely work? What is happening under the hood?
Oof. I don't know.
It's really hard.
It's magic.
It's magic, and
It is. Is that cool, isn't it?
It's really cool, and I think maybe it's not the MT5 paper, but maybe was it XLNet or XLMAR?
XLMAR, yeah.
Where they
Facebook
showed
paper,
where they show that when you have small languages like Swedish, not much data, are actually beneficial or benefited from this multilingual setting, because you could piggyback off the English data, for instance.
It really sounds crazy that you don't really need any text, and you can sort of
Sorry,
chips man. But I mean, like with MT5, how you can pick it up and it can kind of on the fly translate.
Let's move into this topic about monolingual. I think we're still into SweBert land here, and we want basically to maximize the ability to use AI for Swedish text. That's the end goal in some way. Yeah. And one way to go there is monolingual models, and we've done a lot of really amazing work with that, like contrastive
So BERT is a monolingual model.
There are both multi and monolingual versions of BERT, I would say. But in SweBert, we have done mainly, I would say, monolingual versions of language models so far. And one of them is the contrastive tension, and another is the KB BERT, and Arbetsförmedlingen, the AF BERT.
So KB must be Kungliga biblioteket BERT.
Exactly. Yes. And it's really awesome because it really, puts state-of-the-art results when it comes to doing some kind of text classification task or something for Swedish text.
So we even got an internal who can do the best Swedish model, I guess.
There's always a competition.
Always a competition.
So then it comes, and here's a question to you as well. The pros and cons of monolingual versus multilingual. And obviously we can say that it's probably easier to train a monolingual model to beat state-of-the-art result for some specific task and specific language, right? If you train it a lot of Swedish data, you get a lot of high performance there. So then it comes back to, I'm not sure if you heard about Jeffrey Howard's comment.
No.
So he was the president of Kaggle before, and now he's the founder of FastAI. And someone asked him, I think it was Lex Friedman in one podcast, saying, "What do you think about the research being done in deep learning these days?" And he said, "I think the majority of research being done in deep learning is a complete waste of time."
But you have to say that in Australian accent, right?
Yes, exactly. And what he meant is basically, we can see all the big tech giants, especially, and some universities are competing, and even Swedish people in SweBert are competing, saying we can get 0.5 percentage point higher on this some kind of task,
on this sample text.
But they don't really consider the practicalities of using it in that way. It still requires you to annotate a lot of data if you want to use models like this.
Well, this is what happens if you have a metric as a goal, and then you start optimizing for that metric.
Exactly.
It's useless.
That's back to this topic.
Back to this, social media kind of thing.
Yes.
But it's also then the industry and science. What's the metrics? How we want to steer our research could be an interesting angle on this. But let's not go there. Continue.
I think we should try to end the SweBert topic here. I think it's really awesome that we actually do have these kind of initiatives in Sweden, and we're able to collaborate with RISE in these kind of ways.
But do you see? Can you take the next step with SweBert by going into MT5, explore? In a way, start over, but with a multilingual model.
I mean, SweBert is one thing. I think we are using actually different kinds of architectures. So BERT is one, and then there are many others as well. So might be more useful for the kind of language that we're using. But going back to the multilingual thing, maybe we should just bring in all the Nordic languages that are pretty similar, and just get more data and get more leverage, perhaps in particular for the smaller Nordic languages.
Exactly. I like it. And perhaps as a final pointer, and just moving a bit more.
You need to go
generally.
deeper, guys. You promised me, guys. Don't interrupt me, Henrik. I'm going to go deep now on NLP. Let's go, man. Let's go. I don't mind.
But NLP, I would say like this. I started my basic training was I graduated in 97, 98. And in those days, no one actually cared what we did. Oh. It was like, what? And now people are starting to care, and now it matters what we're doing, and with this interest, there are a host of other things coming as well, like transparency, fairness, And all the things, all the explainability and all the tricky things that we as engineers and scientists are like, oh, this is awkward. But it's a sign that society and people are ready.
Wants to make it robust.
Yes, and ready to accept what we can offer.
So now they're asking the tricky questions to really start using it.
Exactly. So NLP is not just about models and scoring. It's also, I would say, predominantly about using things and actually get acceptance.
But if you think about it, the usability is endless.
Yeah.
I so many use cases in so many different...
While we are at that, did we had like any discussion about like the usability of NLP in industry or any type
Let's
of...
go there now.
Yeah, because I think
let's
it's
go
a
there
good way to finish it. It's great to talk about like what it is, but how can companies actually use it? Or even people or startups.
So what is the use? I mean, like I use claim the usability should be endless for NLP type driven processes,
yes.
or really rethink a whole process if you can use the normal text.
Yeah, I can only answer from the point of view of an applied research facility, and I think Anders is more equipped to answer since you have this. You're at a different position, and you're perhaps meeting clients that are more technically adept and know what they're asking for. Our clients are usually, they have to be educated to a certain degree, and so that's what we do, and that's what we can do because we're a government-owned research facility. But let's hear it from you. What's...
No, but I mean, in short, I think, if you compare all the different modalities, as you call it, different types of data that you do have, it can be text, it can be images, it can be audio, it can be time series, it can be, tabular data or numbers simply. And just thinking about, what is the most common type of data format that companies have? I would argue, and what we've heard, is that text is the clearly predominant type of data that companies have. And if we can make use of that in a better way and actually start to understand the meaning of it, the applications of it are immense and more than the other types of data modalities that we do have. Saying that, though, I'm not sure, and just because you said it, we want to go really deep and thinking.
One topic. Pick one.
And I'm not sure. Sorry, Fredrik, for just bringing this on you quickly, but it was a paper coming out from Facebook, I think, just a week or two ago. It was called a unified transformer.
I haven't read that.
But in short, they want to do a multimodal and multitask kind of transformer.
That's cool.
So I really, like the general direction of the research moving into more generic models. That it's not made for a specific task, not just made for sentiment analysis, not just made for question answering, not just made for text classification in some way, but done for many tasks at once, and you can apply it for whatever you want.
It sounds like GPT-3.
No.
This is more. I mean,
I was just.
He likes to.
I'm just teasing you.
The thing with this one, it actually is not only for multitask, it's also for multimodalities.
Yeah.
So then that means that it can handle both text and images in this case. So this is from Facebook, and it came out recently, and they have a shared set of parameters, which is transformer based, with an encoder depending on what type of modality it is. So the image has a different encoder than the text, so but still they have a common decoder. And basically, in short, you can say it's a shared model, a single model that can be used for different tasks and different modalities and combined into one.
So this is truly, now we get into multi-purpose tools.
Yeah, generic AI.
A generic AI.
We're moving towards AGI in some way.
So this is a generic little thingy that can apply to solve different type of problems, but it can be both language problems and image.
And I think the natural idea is to use different modalities to learn. I mean, as humans clearly don't use or learn language. My kids didn't learn language by reading. So there's much more at play, like pointing and feedback and whatever. So bringing text and bringing images and sounds and sensor data and whatnot. I think that's the way to do it.
So what you're highlighting in its small microcosmos, this is going general.
Yeah, I mean, I think it's going in the right direction. It's so much more applicable. The practicality of using these more generic models is very high.
So if I understand it right, instead of having multiple different models for many different things, you can have fewer models that can then handle more use cases.
You train it on the whatever data you have, you want to apply it for your specific use case, and then you don't have to retrain it for that. You can train it on another task, and it still works and learns how to do it. It's like multilingual.
Yeah.
But for multitask and multimodal. So imagine multilingual, multimodal, multitask, everything in once.
All human communication in one model.
At some point in time, it will be a human brain, it's a generic human level of intelligence. And this is very, very far away, but it's moving in that direction. And I like it.
And so this was a paper the other week from Facebook.
Yeah.
And do we know why they are working on this particular problem? What are they planning to use it for? How does it fit into their usage? Or is it actually general research?
This is probably more base research, yes. But the applications, I think, is obvious for Facebook since they have images and text all the time. So I mean,
so they have one model to sort. Then they can simplify the whole infrastructure. They can simplify the infrastructure.
Yeah, and they have not only that. I think they have a moderation problem as well. Images and texts and things that are not good and shouldn't be there. And this is sort of brings to mind one of the things at the beginning of the pandemic. There were reports about the moderation systems and algorithms breaking down at YouTube, Facebook, and Google because the people working with in concert with the moderation algorithms, they had to go home because of the pandemic, and they were not really designed, the algorithms, to work by their own.
And what is moderation?
Moderation, I would say, is to keep track of bad content on the platform.
So moderator in svenska.
Yes.
So moderator.
Handle abuse, basically, in different ways.